Hello guys, welcome to another video in the series of coding. Today we are going to do the problem which is called longest possible path in a matrix with hurdles. So you are given an n into m matrix with a few hurdles which are denoted by 0 and they are arbitrarily placed. You have to calculate the length of the longest possible route possible from source to destination within the matrix. We are allowed to move to only adjacent cells which are not hurdles. The route cannot contain any diagonal moves and a location once visited in a particular path cannot be visited again. If it is impossible to reach the destination, return -1. Let's try to take an example to understand this. So we are given this case, right? Now in this case, let me just start. So you are given source and the source coordinates. X and Y coordinates of the source is 0, 0 means you are starting from this cell. Now the destination X and Y coordinates are 1, 8. So which is going to be this cell, right? Now you have to find the longest possible path which you can take to reach from the source to the destination. Okay, so there are many paths. For example, just consider this simple path. This is one possible path. Okay, consider this is another path. Okay, and so on. Consider this is another path. But you have to find the longest possible path, right? So the longest possible path you have to find. How are you going to find that? Now you can only visit all the cells which have 0. You can never visit a cell. You can only visit a cell which has 1, right? You can never visit a cell which is 0. So if a cell is having the value as 0, you cannot visit it and you cannot include it in a path. Okay, this is the constraint that is given to you, and you can only visit a cell once during your entire path journey. How are we going to solve this problem? So the problem can be solved by BFS or DFS, any algorithm. So let's say we start from the very first cell, right? This is 0, 0. Now I'm going to try to visit my neighbor. How many neighbors do I have? From 0, 0, where can I go? I can go to 4 of my neighbors, right? Let me check. So I can go to 0, 1. I can go to -1, 0, which is not existent. I can go to 1, 0, and I can go to -1, 0. So these are my 4 neighbors. 2 of my neighbors are not existent. So I can go here or I can go here. Let me try going here and let me try the path. So I am trying to go in this neighbor. Now I am entering into this cell. Now I am at the cell with coordinates 0, 1. Now I again have 4 neighbors, right, which I can traverse. But if I traverse this neighbor again, you see what will happen if I traverse my left neighbor again? My right neighbor will go to my left neighbor. My left neighbor will go to my right neighbor. This will again call this function. This will again call this function. I will enter into a recursive infinite loop. I will never be able to come out of it, right? 0, 0 will keep calling 0, 1. 0, 1 will keep calling 0, 0. This will keep on happening. So I need to mark the cells which I have already visited using some number, right? So what I'm going to do to avoid this problem which we just discussed, we don't want to go into the recursive infinite problem. So what I'm going to do, before leaving a cell, I'm going to mark it, right? Before leaving a cell, I'm going to mark it. So let me tell you what I mean by that. So these are my cells, right? So now when I traverse a cell, I'm going to make its value as 2, so that when I visit it, next time my neighbor knows that I should not visit it. So I'm going to make this value as 2. Okay, now I'm going to come into the function call of this neighbor. Now we have 4 neighbors, right? Now I see that I cannot call this neighbor because this neighbor has a value of 2. I cannot call it. Now I will try my top neighbor. My top neighbor is -1, 1, which is not existent. I cannot go here. I will try down neighbor. I will try right neighbor, right? Let's say I try the right neighbor. So I go into the function call of 0, 2. So from this cell I started, I came to this cell, then I went to this cell, right? And so on. Now I can again try going into 0, 3 and so on, right? I will keep trying all the paths, right? And once I reach the destination cell, let's say I reach the destination cell, what I'm going to do, all these cells will be marked as 2. Okay, all these cells will be marked as 2 because we are visiting them. Once I reach the destination cell, I can note the path length. So I will keep a path length variable, and once I reach the destination cell, I will try to note the path length. If my path length is greater than answer, then I will make answer equal to path length. Simple condition. Okay, so in this case, what will be the path length? 1, 2, 3, 4, 5, 6, 7, 8, 9. The path length is 9, right? Whatever it is. So the path length is going to be something. So now after I've entered into this condition, when I reach the destination cell, now I will start backtracking. Okay, I will start backtracking. And once I'm backtracking, I will again erase all the values and make them as 1 so that I can backtrack. Okay, so when I backtrack, let's say I backtrack from this cell. Okay, let me mark the values. Let's say I just backtrack from the last cell. I am again at this cell. Now from this cell, I just went into one path. I will try going into the next path and so on. So it's not very clear right now, and its diagram has also become very messy. But what we will do is we will try to code this and then we'll try to see a dry run, then it will be much more better. Okay, let me just refresh it because the web paint is giving some error. Okay, okay, it's fine now. Let us start coding this. So the logic is pretty simple. We have to declare a function. Let me call it let's say find longest path. Okay, and to it I'm going to pass matrix, I'm going to pass my source coordinates, I'm going to pass my destination coordinates, I'm going to pass a path length which is initially going to be 0, and I'm going to pass something which I'm going to call answer, right? So I'm going to declare a variable answer which I can initially make -1. So finally if I don't find the answer, I can simply just return answer. If I don't find a path, then I can just return answer. Okay, now before this I can simply check if my source is having the value 0. So if matrix of x, s, y, s is equal to 0 or my destination is 0, if any of it is 0, I will never be able to find an answer because I can never enter the cells which have value 0. They all should return false, right? They all should return -1. So here itself I can return -1. Okay, now we have this function. Let me just quickly declare this function. Find longest path. It's going to be a void function because whatever answer we have to return, that we will anyway change here. So we don't need to return anything. So let me just copy this. This is our current matrix, and we have next indices are going to be our coordinates of the cell which we are currently visiting. So initially we are starting from source. So initially x and y will be equal to the source coordinates, but as we progress, we want to finally reach the destination coordinates, and I have a variable next which I can call path length, right? So this is my path length variable, and I have a variable which I'm calling answer. Okay, simple. Now let me start with this function. So what is the base condition is very simple. If my x is equal to destination and my y coordinate is equal to destination coordinate, y coordinate, and then in this case I have reached the base condition. So in this case I have to just check one simple condition. If path length is greater than answer, answer is equal to path length. That's it, very simple. Okay, and I can just return. So that's it, right? So this is the simple condition. Now I can go into the next value, right? I can go into the next. If I don't reach this condition, right, then in that case, when I'm visiting a cell, I have to mark it as visited, right? That's what we checked. And what we are doing for that, we are entering into matrix of x and y, and we are going to make it equal to 2. Okay, so that we are marking a cell as visited, and we don't enter into the recursive infinite loop problem, and we don't take the cell again in the path, right? So we never want to take a cell again, and we don't want to enter into the problem which we just discussed. Okay, now let's start iterating over its neighbors. So let me declare vector. Okay, let's say pair int comma int. Let me call it neighbors. Okay, so these are my neighboring coordinates. So let's say we have 0, 1, we have 0, -1, we have 1, 0, and we have -1, 0. These are my neighboring coordinates, right? Now let me iterate for pair int int neighbor in my neighbors. Okay, what I'm going to do, I have this, right? So neighbor dot first plus my x coordinate and neighbor dot second plus my y coordinate. These are my new x and y coordinates. So whenever I need to find the new coordinates of my cell, I can just add these values to my current cell, and that is going to give my, for example, to the current cell coordinates, if I add this value, then I will get my right neighbor, right? I will get my right neighbor. If I add this value, I will get my left neighbor. If I add this value, I will get my down neighbor. If I add this value, I will get my top neighbor, and so on. I have 4 neighbors which I can visit, right? So to get the new coordinates of the new cell, I can just do this. Now I can give a if condition, very simple. If new x is greater than equal to 0, new y is greater than equal to 0, and new x is less than matrix dot size, and new y is less than matrix of 0 dot size. Basically I'm just checking it should be in bounds, right? And I have to just give one more important condition. Matrix of new x, new y should be equal to 1, because if it is 0 or if it is 2, I cannot visit it. If it is 0 anyway, I cannot visit it, that cell is blocked. If it is 2 means I have already visited that cell, I cannot visit that cell again. So it should only be 1, then only I can visit it, right? If it is, if all these conditions are true, then very simple, I can just call this function again, right? I will just very simply call the find longest path function again. That's it, as simple as that. What are the parameters which I am passing? I am passing all these parameters. Let me just copy them here to save some time. Okay, now in place of xs and ys, we can pass the new x and we can pass the new y coordinates. That's it. That's the only change which we are going to make. And to the path length we can add 1. So initially when we start from source, the path length is 0, right? We are passing 0. Now when we visit its neighbor, path length will increase by 1 every time. Okay, and finally whatever is the maximum path length, that is going to be our answer. That's it. This is the entire code and hopefully it should work. Now there's just one last thing. When we are visiting a cell, now when we are backtracking, we should unvisit it again so that we can use it for later paths, right? Because we can find many paths through one cell itself. So I am again going to make it 1. So when I'm visiting it first time, I'll make it 2 so that its neighbors don't visit it again. So in any path it should not be included again. So I'm going to make it 2. But when I unvisit it, when I backtrack, I'm going to make it back to 1 so that in the next path I can use it and so on, right? There can be several paths to visit from source to destination. That's it. This is the simple code. Now let me compile and see. First of all, it should work, hopefully. Your new y should be greater than matrix of 0 dot size. It should be less than matrix of 0 dot size. Very silly mistake, and I had given the opposite condition. It should be fine now. It's working fine. Okay, let's submit and see if it's working for all the test cases. So it's working. Awesome. Okay. Let us try to do a dry run of our code. So this is our code, right? Let's say it is given that our source coordinates are 0, 0. So this is our source. Let's say destination coordinates are 1, 2. So this is our destination. So from the source to destination, we have to find the longest path. Okay, let's try to find it. Let's start with our dry run. So we have x and y, which we are passing as our source node. So initially x is equal to 0, y is equal to 0. Whatever destination cells, 1, 2, right? And what is the path length? Initially it's going to be 0. And what is our answer? Initially it is -1. Okay, let us start. First condition, we are checking if x is equal to xd and y is equal to yd. So we are checking if our coordinates 0, 0, if that is equal to the destination coordinate, which is 1, 2. It is not equal, right? So this condition is equal to false. Now let us enter into this condition. Matrix of x, y is equal to 2. So because of which we are going to make this value as 2, right? We are marking it, the cell as visited. Okay, let's continue. Now there are 4 neighbors that we have. Now in these 4 neighbors, we are going to iterate over the neighbors one by one, right? Through this for loop. So first neighbor is 0, 1, right? So to the coordinate 0, 0, you add 0, 1. What do you get? You get 0, 1. What is that? This is your this cell. This cell is 0, 1, right? So you are trying to go into the right cell. From the current cell, you are trying to go into the right cell. Let's see if we can go. So we are going to check these conditions. Is your cell in the bounds, right? If the coordinates are greater than equal to 0, if it is less than equal to the size. Now what is the size? Size is 3 cross 3. So you are basically checking if your current coordinates, which is 0, 1, if they are basically less than 3, 3, which is your respective size, and you are checking whether they are greater than equal to 0, 0, right? So you are checking if it is within the matrix, because sometimes your coordinates can go out of bounds, right? So you are checking if this if condition is true or not, because in the next cell you see next coordinate you have 0, -1, next neighbor. Now it is going out of bounds. -1 is not valid, right? Because you cannot go top from this cell. There is no top neighbor. So that's why you have to give this if condition. We have given this if condition. We are checking if it is inside bounds or not. It is in bounds, right? Because our cell, which is our right cell, that is valid and that is existing. Okay. So now let's continue. We are checking if matrix of new x, new y is equal to 1. This is equal to 1, right? So your new coordinates are 0, 1. You are checking if this cell has a value of 1 or not. Because if it has a value of 0, you cannot enter into it, right? But this cell has a value of 1, so we can enter into it. Okay. So all the if condition, all the parameters are true, right? So this if condition is true. This if condition we will enter. So we are recursively calling the function again, but we are increasing the path length this time, and we are passing the new coordinates. Okay. So these are the 2 changes which we are making. So now let me define the function calls. What is our function? Our function is let me just call it function. Okay, we have a function. Initially we are passing 0, 0 as the coordinates, and let me also write the path length. Okay, let me just write the path length. So our path length is initially 0, and these are our coordinates x, y. Okay, and this is our path length. Okay. Now what we are going to do, from this function we are going to make a function call. Now because of this line we are making a function call to our neighbor. Now what is our neighbor? Our neighbor is 0, 1, right? These are our new coordinates. And what is the path length? We are adding 1 to the path length. So from 0 we are adding 1. So our new path length is going to be equal to 1. Okay, this is what we are going to do. But not only this function call, right? After this function call finishes, okay, after this entire function call finishes, we are also going to make a function call to our down neighbor. But first let's finish this function call. Okay, let's quickly finish this function call, then we'll see the other function call. So now what I'm going to do, now I'm going to erase all this. I'm going to just erase these things which I have defined. Okay, now I'm going to enter into the function call of 0, 1. Okay, let me see that. So I am entering into a new function call. Okay, now what is the new function call? The new function call that I am entering into, that is having 0, 1, x is 0, y is 1, and your destination is going to remain the same. Your destination is 1, 2. And what is your path length? Your path length is 1. Your answer is still going to remain -1. Okay, let's take the if condition. Is this equal to the destination cell? Is 0 equal to 1, 1 equal to 2? No, right? This is not the destination cell. This is this cell. Okay, your current cell which you are visiting is this cell 0, 1, right? It's not equal to the destination cell. This if condition is false. We'll make matrix of xy equal to 2. Again we change this, make it equal to 2. We are marking it as visited. Now we are going to visit its neighbors, right? So what is the first neighbor that we see? First neighbor we see is 0, 1. So we are going to visit the neighbor 0. So what is our current coordinates? Current coordinates are 0, 1. To the current coordinates you again add 0, 1. What becomes the new coordinate? 0, 2. This becomes your new coordinate. So you're going to visit this cell, right? So again you enter the new coordinates are 0, 2. If condition is true, it is within bounds, it's having a value of 1. So we can call the new function, right? So this time you are again going to call the new function. Okay, I'm going to call the new function. Let me write it. So what we have done, we have made this cell value as 2 and we are going to call the new function. What is the new coordinates? New coordinates are 0, 2 and the path length has again increased by 1 and the path length has become equal to 2. 1 plus 1 is equal to 2, right? So this is the new path length. Okay, now let us try to see the condition for the new function call. So you can see that new function call, the coordinates are 0, 2. The destination remains same, which is 1, 2. Path length becomes equal to 2. Answer is still -1. If condition is false, this is not equal to the destination cell because this is your destination cell, but currently you are iterating over this cell which has a coordinate of 0, 2. Okay, now we are going to again using matrix of xy equal to 2, we are going to make this value as 2. Again we are going to visit its neighbors. First we'll try visiting the right neighbor. Okay, now what is your current coordinate? 0, 2. If to the right neighbor, if you add this becomes equal to 0, 3. 0, 3 is not existing, right? There is no coordinate 0, 3 in this cell, so we cannot visit this if condition is going to be false. So what we are going to do, we are going to try visiting the next neighbor 0, -1. If to 0, 2 you add 0 and you add -1, what is the coordinate going to be? 0, 1. So you are trying to visit this cell, you are trying to visit the left cell, but you see that it is not equal to 1, it is already visited. This if condition is also false, right? It's already visited. If this cell is already visited, how can you visit it again? You cannot visit it again. So even this is not going to be acceptable. So this failed, this failed. Let's try for this. So our cell coordinate is 0, 2. We are trying to visit, we'll add 1, 0. This becomes equal to 1, 2, right? So this is valid. Now you'll try to visit the cell 1, 2, right? So let me rewrite the parameters. So here let me change the function call. Okay, so you are going to try to visit the new cell which has a coordinates of 1, 2. Okay, let me write the new function call. New function call, you are trying to visit the cell with the coordinates 1, 2 and path length equal to 3. Okay, now let me start. So the x is equal to 1, y is equal to 2. These are your new coordinates. Your destination is coordinates are also 1, 2 and your path length is 3. Answer is still -1. Now first time you're going to enter into this if condition, this is equal to true, right? Your x coordinate and y coordinates are exactly matching. 1 is equal to 1, 2 is equal to 2. So you are going to check if path length is greater than answer. You are checking if 3 is greater than -1. Obviously 3 is greater than -1. So in the answer you are going to change and you are going to make the answer equal to 3. Awesome. So we have made the answer equal to 3. Okay, so our answer is going to change for the next time. Next time answer will become equal to 3. Okay, that's it. Awesome. Now you are actually going to return. You see this line return and you're going to return back from here. Okay, so now we are going to return back. So this function call is just over and you're going to return back. Okay, when you return back, you're again going to go in the function call of this function, right? you have this function called remaining. Now in this function call, what happened, you tried visiting this, from this cell you tried visiting this does not exist. You try visiting top, you try visiting left, you cannot visit it, it's already visited. So all these function calls failed. Only one function call was successful, and you finished that function call and you came back, right? This function call is also over. So all your 4 function calls are over. So for the first time you will enter into this condition, matrix of xy equal to 1. So what you are going to do, you are going to enter into this line, matrix of xy equal to 1. This means that here you are going to change the value and make it back as 1. Okay, this value which was earlier 2, we are going to make it 1 because of this line. And now this function call is finished, this function call is also finished. Okay, this function call is finished, means you can return to the earlier function call. Okay, you are returning to the earlier function call and you are backtracking, making this value as 1. Okay, done. Now let's come into this function call. We were in the function call of, let me change the parameters. So we were in the function call of the coordinate 0, 1, right? The coordinate 0, 1. So we are into this function call. What we did in this function call, we went right side, right? First function call we saw, first neighbor we saw, and we went right. Okay, so this is done. Now in the for loop, we'll try to visit the next neighbor. Next neighbor, what are your coordinates? Current coordinates are 0, 1. Current coordinates are 0, 1. Okay. So from 0, 1, you tried visiting the right neighbor, the function call is over. Now you will try visiting, you will add 0 and minus 1. When you add 0 and minus 1, the coordinates become equal to 0, 0. So you will try visiting the left neighbor, but it is already 2, right? Its value is 2. It is visited. This if condition will be false. It's already visited. So you cannot visit it again. Okay. So this is also not valid. Now you will try visiting the down neighbor. Okay. So let's try visiting the down neighbor. Let's see what happens. So you are having the coordinates 0, 1. You try visiting the down neighbor 1, 0. You add 1, 0 to the coordinates of your current cell, right? You are adding to x and y. You are adding the coordinates 1, 1 and 0. So it becomes equal to 1, 1. Now you see 1, 1 has a value of 0. This is not a valid path, right? It has a value of 0. So this condition is also false. You have to have a value of 1 to visit the cell, right? This cell is having a value of 0, you cannot visit it. So this condition is also false. You cannot visit this cell because it has a value of 0, right? So you cannot visit. Now let's try visiting minus 1, 0. It will go out of bounds, right? If you add this will become minus 1, 1. Now this cell does not exist. So all the 4 neighbors are done. All the 4 neighbors are done. This for loop is done. So you will again make this value as 1 and you will return, right? So let me quickly make that value as 1 and let's just return. Okay, so what you are doing, let me erase all this. So what you are doing, you are entering into this line. This line is telling you to make this value as 1, to change the value as 1. So let me just do that. Okay, let me just do that. Change the value as 1. So this function call is also done. Now we are again coming back to the first function call 0, 0, 0. Now in this function call 0, 0, 0, what happens? You are going to in this function call 0, 0. First you tried going right side, right? You tried going right side using this 0, 1. This is done. Okay. And now you will try going left side. Left side is out of bounds. This is not valid. You will try going down 1, 0. You will try going down, right? Once you try going down, this is going to be valid. You are again going to make it as 2, and then again you will try going down. You are again going to make it as 2. You will try going right. You are going to make it as 2. You will try going right. You are going to make it as 2, and then you will enter into this coordinate. Now this coordinate is going to be your destination coordinate. So your path length, when you do this, your path length is going to be equal to what? 5. In this case, you can see that the path length is equal to 5, and this will become your answer. Your answer will become equal to 5. You can do the remaining dry run yourself and you can check. So answer will become equal to 5, and after that you can again backtrack, make all the values and 1 and try to find the remaining paths, which will not be possible. So your final answer will be 5 and you can return 5.